All right, so what we're going to be talking about in this lecture is a very quick idea, and it's really just vocab, to be honest, but it's not a bad way to be thinking about these linear equations that represent real life situations, because oftentimes we're not dealing with infinite values and values that can go on forever and ever. We have finite resources, we have finite time. So oftentimes having an idea of reasonable values that would go into these equations is helpful. And that's what we're talking about here with this ideas of domain and range. And trust me, we're not talking super complex ideas. So the definitions. So the domain is the set of all possible x values for a linear equation. All the x values that could go into an equation, a linear equation in two variables. Oftentimes, that number's infinite. It could be anything, especially if we're dealing with just kind of a plain old linear equation without any context. It could be infinite, uh, but or all real numbers. That's another way it's often put, is all real numbers, which means just numbers. Whereas you put it in a particular context, when you put it in a particular situation, then it might be more limited. For anybody that played the marble slide game on Desmo's Classroom, we noticed that sometimes they changed that. You would see something in the corner that looks like this, like, or off to the side of the equation. X was less than or equal to 10, right? Well, that's one way to say x is not any bigger than 10. Our range is not going to go above 10. And for whatever reason, our pizza example, Sal's House of Pizza, you know, x was the number of toppings. Well, they might not have more than 10 toppings. So that in that case, x isn't going to be above 10. So depending on the context or the situation that the equation represents, you might have some you might have a domain that is not infinite. The range, as you can probably figure out, if the domain is the set of all possible x values, the range is the set of all possible y values for a given range. To find out what the range value is, it does depend on what you've established for the domain. So if you said in Sal's House of Pizza, for instance, that you the number of toppings uh, can't exceed 10, then the highest range you could have is whatever. Um, I think it would have been 30, because I think in Sal's House of Pizza, the price of the pizza cost $1.50 per topping plus $15, right? So if we said that y was 10, or the highest x was 10, the highest you're going to pay for any topping for any pizza at Sal's is $30. So this is a situation where we're looking at this and saying, okay, well, all right, based on this, um, our y values actually are going to fall between 15 and 30, because you're not going to pay any less than 30 or less than 15. You're going to pay 15 to 30. So that's mathematical speak for um, anywhere So let's go through an example of how we might establish the domain and range for a scenario we kind of talked about. We're talking about a lemonade stand here. I think we used this example in one of our practice ones. So Don Don, our friend Don Don, is running a lemonade stand on a hot summer day on a parade route. So there's a parade going by, hot summer day. He's charging 50 cents per cup and has invested $10 in supply. So between the cups and the water and the ice and the lemonade mix, he's $10 in. So the linear representation, the linear equation that represents his profit is, so take a minute, hit pause, and try to come up with, or try to remember, what the linear equation that represents this situation would be. Remember, we're talking about profit, which is income, money coming in, minus cost, money going out. So hopefully, when you gave that some thought, you came up with the profit would be determined by how much money he has coming in, which is 50 cents for every cup he sells. So the number of cups is our independent variable. The total profit is the dependent variable because it depends on the number of cups you sell. 0.5 or half or 50 cents is the slope. It's the rate of change. That's how much profit is going up every time you sell one more cup. And then $10 is the constant because he's not going to spend any. If he spends, or if he sells no cups, he's going to be out $10. So what would a reasonable domain be for this situation? Again, hit pause. What do you think a reasonable domain would be for this situation? So if I'm looking at this and saying, well, what could, when we're talking a reasonable domain, we're talking real world here, right? I'm going to look at it this way, and this is kind of some new notation. I don't care how well you make those brackets. Right? I'm going to put X right in the middle, right there. And I'm going to put these symbols on either side. On the left side over here, what's the lowest number X could be? Well, maybe Don Don is setting up his lemonade stand next to a parade of people that don't like lemonade. So he might sell 0 cups. That's the lowest he could possibly sell. This is a situation where he's dealing with real things. He's dealing with cups of lemonade. The idea of selling negative doesn't make any sense. So we know the lowest is going to be 0. Right? On the high end, well, this is where you might want to get a little more just kind of reasonable. There's no really right answer, but parades don't last all that long, but it is a hot day. So let's just say, for instance, he sells 40 cups of lemonade. That might be too low, it might be too high, but it's within the realm of reason. Don't say 4,000. He's not going to sell 4,000 cups of lemonade, and he's not going to sell negative 15. He's put a reasonable value in there. So that's what our X could be. Again, now that we have established a domain, now that we have established what our X values could be, what we think they could be, what would a reasonable range for this situation be? Hit pause again, see if we can't figure it out. So when you're figuring out the range, right, we're going to do something similar notation-wise. I'll explain. I didn't explain before what those mean. Okay. So when you have y right in the middle of this, it's saying y is greater than the number on the left, greater than or equal to the number on the left, and less than or equal to the number on the right. It's going to be within those two values. That's just math speak, but for those. For what that's saying, in between these two values. So if we take our first X value, we have to go back to the range, right? And we say he sells 0 cups. We plug that in, that means y is going to equal negative 10. If he doesn't sell any cups, his profit, he's going to be losing money. He's going to be out negative $10. If we go to the high end and say he sells 40 cups, 0.5 times 40 is 20, half of 40 is 20, minus 10 is 10. So given the range that we've established in part one, given the domain that we've established in part one, his range would be somewhere between negative 10 and 10. So that's just how to be thinking in terms of what's reasonable for an equation. What makes sense to have for particular x values and y values. So domain and range are just what could the x's be, what could the y's be. Be sure to get some practice on this once you've finished these notes. Get plenty of practice. We'll go over this later in class. Hope this helped.